Hi everyone, welcome to this catch-up demo sessions for my talk at TechEd 2013 here in Australia. My session was named Cross-Device Notification Services with C#, Xamarin and Windows Azure Mobile Services. For those of you who came along to the session, you will have known I had some challenges getting the demos to work, so I thought it would be great if I could run you through the demo code so you could see for yourself firsthand all this great stuff really working. Before we get into the actual demo itself, let's just refresh ourselves with what the demo was supposed to be about. I forked a copy of the Xamarin Mobile Services samples and particularly their Tasky Pro sample app. I created a task manager that allows us to assign tasks between different people in the application, and as those people use different devices, generate a push notification to the particular user. For the purposes of this demonstration, we have three users, Larry, Steve and Tim, each of whom has their own particular device of their own flavour, one of each of the three main versions of the mobile platforms currently in the market today. Let's just take a quick look at what our demo architecture looks like. So on our handsets we'll have the Tasky Pro modified application deployed, and then pull in the appropriate Windows Azure Mobile Services assembly provided by Microsoft. This will push our messages in a JSON format to the REST API of Windows Azure Mobile Services, which in turn will forward on that request to Node.js. The Node.js wrapper methods for the database will insert the data into the database for us and post that insert, leverage the configurable push notification gateway service for mobile services to actually forward the message out to the native push gateway service provided by each of Microsoft, Apple and Google, which will then eventually deliver the push notification back to the handset, where standard local push notification handling logic will actually surface that to the user who's using the device at the time. Our demo database in Windows Azure Mobile Services is pretty basic. This is what it looks like. We have a user device registration table. For the purpose of this demonstration, we assume that one user is mapped to a single device, and we have a table which contains user tasks. And there's a one user to many user task relationship here, although we only send out one push notification when we first initially insert the task into the task table, as we see later when we look at the Node.js database front end that we've written for that user task table. So let's start by having a look at the iOS demonstration. So those who attended the session would have seen this work up to a point. I had some challenges actually getting this to publish the application through to the device attached to my Mac build server. As one of the challenges I had in prepping for the demo was if you left the Apple and Windows machines on for a period of time with Visual Studio open, Visual Studio lost connectivity to the build host running up on the Mac machine, so it was a real challenge to get that to work as expected, as you saw on the day. For the purposes of iOS development using this setup, this is what our environment looks like. The Windows machine's running as Visual Studio 2012, so it has to be professional or above. We're using the Xamarin Business Edition license, so we have the ability to leverage the Xamarin iOS extension for Visual Studio. This Xamarin iOS extension then talks via the network to a Xamarin build host that you deploy onto the Mac OS X box, which in turn leverages the build capabilities of the Apple iOS SDK to actually cross-compile the C# and Mono application that you've built, or Mono Touch application that you've built, across into a native Apple iOS ARM app, which is then deployed to the device. I show iOS device and iOS simulator here. I'd certainly recommend, if you're planning on doing a lot of development, that you buy a device of the type that you're primarily going to be deploying to. The iOS simulator is fairly limited in its capabilities, and for instance something as simple as a push notification can't be handled by the iOS simulator, which means for this demonstration we'll actually be using an iPhone attached physically to the Mac OS X build server. So let's take a look at how we get our APNS push certificates registered in the mobile services console. So here I'm actually logged into my Mac build server. I just want to quickly show you I've already set up an application ID for the Tasky Pro push app that we're looking at today. So you can see here it's already pre-registered. The important thing is when you create these particular app identifiers, you want to make sure that you actually have push notifications set as configurable or enabled. Otherwise you'll have some challenges around that. So what I've done is I've enabled push notifications on this already, so it shows as disabled at the moment. I'm not sure why that is, but it's been previously enabled. And then you can actually from this point create certificates if you want to. If you've already done that part and you don't want to do the certificate creation from that point, you can use the General Certificates tab that we have up in the iOS developer portal, and we're going to click the plus sign. So for our demonstration we're going to use a sandbox certificate. You can also create a production certificate. The Azure portal supports both, so when you upload the certificate you can choose whether it's for dev or production. Obviously worth ensuring that you have the two separated, because you'll probably have problems if you try and use your dev certificate for production use. So for today we're going to create a sandbox SSL certificate. We'll click continue. So we're going to use the pre-registered app that we've already got, so we don't need to change that. As I've only got one app I don't have to choose. Alright, so at this point I need to create a certificate signing request. The easiest way to do that if you are using a Mac is to use Keychain. If you're not on a Mac, you can still achieve it using something like OpenSSL and or the CSR request manager inside of IIS. I'd certainly recommend the easiest way is just to use Keychain, because that's what the Apple documentation's covering, so you'll probably be on your own if you're trying to cover how you create CSRs and create APNS certificates using any other approach. So I have it down here on my docs. I'm just going to go and launch the access, and if I come over to Keychain Access and Certificate Assistant, I can then choose to request a certificate from a certificate authority. I'm going to click on that. I'm going to add my email address. I'm going to save it to disk and click continue. I'll just save it for our desktop. I'm going to make sure it's got a unique name. So we'll click done on that. Okay, so now that we've got that saved to disk, we can actually go ahead, click the next button, and it will prompt us for where to find that file. So let's choose the file. It's on the desktop. It's the only one that's there. We'll click open and then generate. So this will actually generate the certificate that we're actually looking for. Okay, so this is our certificate, so we're going to download that. So that's a certificate file. Now we need to convert that into a PFX file to allow us to upload it into the Azure portal, so it contains the private key that we want. So what we're going to do is go ahead and just show this in the folder. So you'll see I have a few in here already, and then what I'm going to do is I'm going to do open with Keychain Access. Alright, so that's just been imported, so you'll see it's here, it's the first one at the top here with my private key attached. What I want to do is I want to actually export this. So P12 is the right format. I'm going to save it to the desktop. What I'll do is I'll call it SSS certificates. So this is the private password, or the password to protect the private key that's going along with the PFX. So we'll type an ultra secure password that is of fair strength according to that. Now this is actually my administrative login to this Mac password, because the activity that Keychain's about to do requires admin access. So this is like user access control in Windows. So I'll type in my user password and click allow. So that's now done. So if I go back to my desktop, I find that I have a P12 certificate here. I should be able to hop back to my mobile services tab and click upload. I'm going to browse for the file. It's on my desktop, so I choose the P12 file. Okay, I need to enter the super secret password that I entered before. This is my dev certificate, so this is the password for my private key attached to this PFX. I click OK. So it will actually upload and do whatever unpacking it needs to actually unpack that certificate. So it's continued to run for a little while. So that's been successfully uploaded. So now that we've got the certificate generated and our service is ready to do push, let's go ahead and see how we can leverage push notifications in our app inside of Visual Studio using C# and Xamarin. So here we are in Visual Studio 2012 with the Tasky VS solution open. If we have a look over on the left in Solution Explorer, we can see that we've got a project for Android, a project for iOS, and a project for what was originally Windows Phone 7 but now cross-compiled to Windows Phone 8 in this environment. For the purposes of this demonstration, I've created a folder which contains both the database scripts and the Node.js scripts that front those database tables. An important note that if you deploy database tables directly into the SQL database that backs your Azure mobile services front end, you may not actually see the tables or columns appear as expected in the Windows Azure management console or management portal on the web. So you're better off leveraging the dynamic schema capabilities of Azure mobile services and push in objects to initiate the database and then turn off the dynamic schema if you don't want it to change any further. As well as these two items from Windows Azure, we also have this mobile services managers folder, which contains a manager file for each of the two tables that we saw in the earlier diagram, and they're implemented as singletons just so that we are careful about how we make our calls to and from the Windows Azure mobile services. Theoretically, because those REST APIs can be called asynchronously, there's probably not much of a need to worry too much about this, but it does mean that we don't have, I guess, leaky classes where we have instances of the Azure mobile services client hanging around indefinitely once someone has called that, and then maybe it ends up running on a different thread. So we have to remember each of these individual mobile platforms is multi-threaded, and as we'll see, there's actually some asynchronous C#5 code inside of these device managers to allow us to do some of the newer, funkier asynchronous programming that we're now seeing come out as part of the C#5 changes that have been made that are now part of Mono and the Xamarin platform since July 2013. If we try and build this solution, we'll find that there's a bunch of failures, so let's just go ahead and try and build this. You'll see at the bottom that we've got a bunch of failures. These are all related to the fact that we haven't yet added the appropriate Windows Azure assemblies to each of the particular project types. So you'll see there's a bunch for Tasky Android, Tasky WP7 and Tasky iOS. So let's go ahead and fix that. So if we come over to our Solution Explorer, and I'll just pin that so it doesn't go anywhere, and then expand it a bit so we can see it. What we want to do is, when we use Xamarin, we'll see that both the Tasky iOS and Tasky Android projects have this new components folder, which has this funky color, so it stands out amongst the flatness of Visual Studio 2012. And this is effectively the NuGet service that Xamarin has come up with to allow them to basically take you to their component store, where you can either buy components or pull components out off the shelf that are free of charge. So let's go ahead and fix this issue for Tasky Android. So I'm going to right click on that components. If I zoom in on that, I've right clicked on that and I now get more components. So I'm going to click on that, and what will happen is I'll get a dialog box open. So let me go ahead and click on get more components. This dialog opens, and hopefully in a relatively short space of time we'll get a web page load. Sitting up here right at the top on this first page, we can see Windows Azure Mobile Services, which is highlighted now for blue. So I'm just going to click on that. It'll take me to a page that gives me a bit more information about Azure Mobile Services and a demo on how to use it. All I want to do at this point is go ahead and add to app. So you'll see that if I expand this folder now, I've now got Azure Mobile Services being added to, this is the Android project, but I'll do this in a second for iOS. It's been added to the components folder, and I now have a reference up here under references pointing to Microsoft.WindowsAzure.MobileServices.Android. If I go ahead, I can repeat this for iOS. And the great thing for most of these components is that they come with sample code as well, so you can see how to use them. It's not surfaced inside of Visual Studio, but if you go and have a look at the folders on disk where those component files are being saved, then you'll find they've got documents quite often and simple apps to help you understand how to work with these items. So looking here again under iOS, we have the Azure Mobile Services components been added, and then we have a reference that's been added which points to Microsoft.WindowsAzure.MobileServices.iOS. Now the reason that our managers classes sit outside of a project or a solution is that everything resolves to this Windows Azure .mobile services namespace, and that it doesn't matter whether you're on Android, iOS or Windows Phone 7, as we'll see. They live in different assemblies, but they all have the same namespace, which unfortunately means we can't have this class sitting in a single project because we can't add 3 references to 3 different assemblies that all provide the same namespace. So the easiest way to get around that is to have them as a solution item and then add them at the appropriate point in the project as references or as linked items. So let's just have a quick look at how we do that, because they're already included in these 2 projects. So if we have a look in business layer here, I'll go ahead and I'll delete the user device manager. I'll do add and then add existing item. I'll go back up the stack and find our mobile services managers folder, which is where our items are stored. Select the C# file, and then down here under add, I'll choose add and add as link. And you see it'll be added, and it has like a little blue icon, which is an arrow that's suggesting that it's actually included as a linked item. So most of the items inside of Tasky.core are included at one point or another throughout the other applications as linked items. So it's a great way to centralize a lot of your code, even if you can't add a reference directly to it. And even the Windows Phone 8 application has some of those challenges, because you can't include some of the classes that are inside Tasky.core because they won't compile or deploy to Windows Phone 8, but you can certainly use some of the C# that you've written to allow you to leverage as much common code as you can. So finally, let's just go ahead and quickly add the NuGet package for the Windows Phone 7 app. So I'm going to do manage NuGet packages for this application. I'm going to type Azure Mobile Services. Oops. So it's the second one here, so let's install that. So it'll pull down a bunch of other dependencies that it has. So we'll accept this. So at the moment all we're doing is we're currently solving build failures just because we're missing some assembly references. So we should now see that the mobile services client and all the various items relating to mobile services are now resolving and working as expected. So we should now be able to build this. So build succeeded, that's great. Now interestingly, if we look up here at the top, we'll see that it's showing my iPhone. So I currently have my iPhone attached to the Mac build server, which we'll VNC into in a moment to have a look at. And because of the way Xamarin is set up and the way it's hooked into what's going on the Mac, it can see that I actually have an iPhone attached at the moment. If you want to use the simulator, which as I said earlier can present some challenges, the way you actually need to go ahead and do that is you need to actually come in and change the configuration. So you'll see here at the moment in the middle it says, whoops, press the right key would help. At the moment it says iPhone, so what we would actually need to do is we'd actually need to change this to iPhone simulator, and then we'd use the simulator instead. For this demo we need to leave it as iPhone because we need push notifications to work, so let's go ahead and just leave that and close this dialog, and then we'll go back and let's just collapse all of this so we can just see the iOS application. So what we've had to change in the iOS application is in the home screen, which is where most of the business logic lives. We have a call to task manager insert for saving a task. So we're not trying to update tasks in this demo, we're just simply going to insert it and assume that that's what we're wanting to achieve. In our populate table method, which loads a list of tasks assigned to this particular person, we load the tasks using an asynchronous call, and we call get tasks for user, and we're hard coding the iPhone instance of this application to look for tasks for the user whose name is Tim. And once we get those tasks back, we'll actually go ahead and populate a particular list of items as they show up on the application main screen. In app delegate, on finished launching, we're going to register this application in this code block here, so that we actually get remote notifications being pushed back from APNS, and we're registered for alerts, badges and sounds. And then later down here, what we're actually doing is once we're registered for remote notifications, we're actually going to insert this information into Azure Mobile Services in the user device registration table, so that we know that the user Tim is using APNS, and this is the service key that we'll use when we send a push notification to this user. So this service key is unique per device, and this way we're tying any task that's assigned to Tim to be sent to this particular device token. So that's really the level of code change that we've had to make to the out-of-the-box Tasky Pro. There is a drop-down that was added on the dialog screen to allow us to add other users to be assigned to. It doesn't affect the way the mobile services or the push notification services stuff works. So let's go ahead and see how we can go on this. First of all, I'm just going to check quickly in our output window. I can come and have a look at our Mac server log down here and see if everything is happy, which it looks like it is. That looks all pretty good to me, and the fact that we can see the fact that my iPhone is attached to the device is also a good thing. So let's go ahead and start debugging this. So it says remote building down the bottom here, so let's pull up VNC. So this is my Mac machine that's attached just to the side here. I'm going to pull up iTools, which is a great little simple feature to allow me to see the screen of the attached iPhone. There are others on the market, none of them overly expensive, and there's typically the ones you see in other demonstrations. So it takes a little while to spin up the build, as you can imagine. Let's just see how we're doing for output. So that's great. Alright, so it's finished doing the build. So it's actually pushing this across the wire to Mac build server. We should see eventually that our screen, let's just resize this, there we are. So we've pushed Tasky up onto the device there. So if I grab the device with my hand and I'm going to open that, so this may crash because it hasn't opened. It should automatically open when it's put into debug mode, but that's Tasky loading there. Okay, so it has crashed on us. That's fine. Alright, here we are. So it's now pushed the application onto the device and is debugging it. So I'm going to whack this plus button on the side here. So there's a simple form. So I can actually go ahead and actually assign something to someone. So I'm sure you can hear that ticking away in the background. I'm going to leave this one assigned to Larry. I'm going to save this. Alright, so that's actually a breakpoint inside Apple app deployed onto an Apple device, but it's inside Visual Studio in C#. Hit F5, takes me back to the home page. So while we're here, let's go ahead and add another one, just for good measure. We'll assign that to Steve. We'll save that. So again, we can see that we're running an ARM app up on our iOS device, in this case an iPhone, and when we hit save task, we're actually getting a breakpoint here at the very end of this method, which is pretty amazing. So what happens is the Xamarin code gets deployed with our own custom debugger. So obviously this application's footprint is slightly bigger than a final build would be, because they don't obviously deploy with a debugger for a release build. So let's just go ahead and hit F5 on this. So we should now see, if we look back in VNC, that's now back home. So that's cool. So let's go ahead and exit out of Tasky Pro, and then we'll stop our debugging session, which is good. So the great thing is the application will actually stay on the device if we want it to. We don't actually need to go ahead and change anything, so we can actually go back and test with that build if it's all good, if we really want to. So what did that do behind the scenes? Let's go have a look in our demo database here. So I've already changed over to Azure Mobile Services inside of the Azure portal, and here you can see we have our two tables. We've got our user device registration table and our user task table. As we would expect, given this is the first device, there's only one registration in here at the moment, and that's for Tim, and he's registered for APNS, and there's his service key for this particular device. There's a script attached to this table for insert, and because there's some challenges around, particularly the way Windows Mobile registers itself and occasionally updates its registration, what I've done is I've just written a pre-insert trigger, I guess, for want of a better description, where we actually look up the user to see if they currently exist in a table, and if they do, what we do is we actually go through and we delete all their entries. Simple demo, so we're assuming that we'll only come across the user once. So we delete all their records, we log it, so we can see that record deletion actually back in the mobile services log, which we'll take a look at in a second. And then finally we insert our new record. Excuse me. So in the user task table, we just created two tasks. So we'll see that in this table we've got our task name and notes, whether it's done or not, and then who the actual assignee is. So the assignee is the item that creates the trigger of the action, and we have a task associated with, a script associated with this table as well on insert. This one's slightly more complicated than the other one. So when we've successfully executed the insert, so this is a post execution trigger, what we actually do is we send back a response to the caller, so that frees up the client to move on with whatever it needs to do next. Then we use this technique to actually query the SQL Server sitting behind the scenes to allow us to do a join between the user table and the task table. So what we're doing is we take the task ID, the task and the task name, and the device or the user device service type and the user device service key, and then we get that as a result of a join between the user task and the user device registration table, and that's based on assignee and name. So we're assuming that the name that's held in the device registration table will map to a name that is held down on the device for allowing someone to actually assign a task to that person. And then we use this placeholder query format, which basically says we'll provide you with this ID later. So that's a bit like using the query parameters for standard SQL inside a .NET, and help protect yourself against some nastiness generally, as you can imagine, on this sort of interface. Then we invoke the node module called MSSQL. We run the query, we provide the query string that we wrote previously, and then we provide the item ID as it comes in. So I don't know if you've seen this new features inside of Node, where you can actually, the node editor, where you can actually come in and do some pretty cool stuff in here, starting to get a little bit more complicated in terms of the stuff that you can do, which is pretty cool. And I saw a really cool session at TechEd from Glenn Block on this stuff as well. So recommend you start paying some attention to this space if you're not already working in it. On the SQL query, if we succeed, so that means that we got a result back, or we got no error back, and then we check to make sure that we actually did get some results back. We first of all log it, then we just have some simple variables to make our follow-on code a little bit neater. So we find the service type, the unique identifier for the recipient, so that will vary by service type, and then what the message content is going to be. And then we switch by service type. So service type will be one of three entries. It'll be GCM for Google Cloud Messaging, APNS for Apple Push Notification Service, and MPNS for Microsoft Push Notification Service. And then we use the native or the Microsoft supplied push node module to actually invoke the send method for, or send function for the GCM, APNS or MPNS components of that push node module, and format the message with the right format, and then just log the success or failure. So let's quickly have a look at the logs to see what we're logging here. So we should see some interesting stuff appear. Alright, so it looks like we've got an error there. Let's just click on that, see what happens. Could not find registration for supply. Yeah, okay. So because the other two guys aren't yet appearing in the table, when we try and look up these guys, we're getting them back. So you see here both Steve and Larry resulted in a failed lookup for their registration, so we couldn't send them a push notification, which is fine. That's we would expect that. We've got the data here, so we could theoretically, when they do register at a later point in time, use a insert trigger to actually capture that, look up any tasks that are sitting in the task table, and then push them out to them. So far we haven't seen any of the push notification stuff, but we'll finish that as we go through the three applications. For now, we've got the Apple app actually saving the task back up into Windows Azure Mobile Services, as well as the device registration. So that device registration won't change for my device now, which is great. So I'm going to go ahead and go from the Tasky iOS app over into the Android app. So let's change that to be our startup project. And before we do that, let's just quickly hop back into PowerPoint just so we can see what the Android development setup looks like. So this is somewhat simpler than the Mac environment and the iOS environment because we can leverage the Android SDK directly inside of Windows. We're still using a Xamarin extension. We're using the Xamarin Android extension this time, which allows us to do the development inside of Visual Studio as well, and then has an inbuilt SDK manager and emulator manager as well, so we can set up all various sorts of configurations. And then under the covers we leverage the Android emulator, or we can attach an Android device. For this demo I'll be using the Android emulator because I don't have a Android device to hand, but the emulator works really well. One item to note, and it's a gotcha if you're not used to working with Android emulators, is that you must have an Android emulator along with the Google APIs. By default, the emulator doesn't include the Google APIs, which is a real problem because a lot of the sort of stuff you do, like push notification services, relies quite heavily on the Google APIs, so you'll find that you'll just be banging your head up against a brick wall without pulling in the Google APIs. The other thing to note is that Google started introducing a thing called Google Play Services, which is gradually replacing a lot of the sort of traditional ways of doing things. What we'll see for the GCM code that I'm going to write or show you in this particular build of the Android app, this is fairly old but works, but the approach is deprecated, and Google would prefer that you start to use Play Services. The good thing is, and we'll just talk quickly about this, is that there is actually a Xamarin component available from Google, which does Google Play Services. So let's just search for Google Play Services. So you'll see here that there are several versions of this available depending on the age of the particular device that you're trying to target. The thing I don't really like about this is that for obvious reasons, Google doesn't guarantee that this Google Play Services capability will be available on every device. So you must probe for its availability on the device before you leverage it, which means you've got to start writing a bunch of workaround code in the event that it's not actually there. The approach I'm going to show you is working right now. There are some other options available, which we'll talk about later, but that's something to be aware of because you're starting to see a lot of traditional methods being deprecated by Google inside of the APIs, which is going to introduce some changes into the way you do some stuff. So let's go ahead and close this dialog, and we'll just do a quick walk through the Android device. So the changes that we've made inside the Android device, we have this register for notifications method call inside the onCreate method inside of the home screen activity, and all it's doing is it's going off and it's creating an intent with a request to register for the cloud messaging service, the traditional cloud messaging service available from Google, and then it's providing this sender ID. So let's go ahead and see where we get that sender ID from. So what I'm going to do is I'm actually going to go across and go into the Google API console. So we just need to log into this. So here we are at the Google API console. We're just going to log in, so let's put password in there and sign in. So I already have a project here. If I had no projects here, then I wouldn't see this, and I would just get a nice blue box asking me to create a project. This is the project that I set up for the demo I did at TechEd. So I don't need to change anything on this. You can see that I have Google Cloud Messaging for Android enabled, and I have my project number. So the project number, if we go back to Visual Studio, you'll see it looks awfully similar to that sender ID there. In fact, it is. That's the way we tell the Google Cloud Messaging component that this is who we are in their world, because they have obviously many applications running in this space. In order to have API access, I must have created a server key. I have no IP addresses registered against this server key at the moment. Setting that up for something like a cloud service provider like Azure would be quite challenging. So what we do is, once we've created that, we need this API key. So we'll take a copy of that. We go back to the Mobile Services console. We click on the Push tab, and we'll see at the bottom down here we have an API key. So that's an old one. Let's go ahead and put that in. And then because we didn't change it, it's not letting me save it. That's fine, because that was a key that was already there, so that was copied out for the demo. So that's alright. And then we would save that, and that would allow our Azure Mobile Services backend to effectively impersonate us and call out to the GCM console. So at the moment we'll see that it's all good and it's all running, and there's probably not going to have been any messages sent via this at the moment because I haven't set anything up. So we'll leave that open, we'll come back to it later. So let's, for the time being, go ahead and run this Android app. So because I haven't run this before, it'll ask me to select the device to use. I don't have any running devices. I have no physical devices attached. I have no emulators running, so let's click on Start Emulator Image. I'll choose API 15 because I know this emulator works and it's the one I've been working with previously. So that loads up on screen. It'll take a little while to boot up. So here it is, it's booted. So let's just unlock it so it doesn't complain. Okay, so the app's still compiling. So again, we can come and choose the emulator now that it's running. We'll click OK. Again, if we look in output, we can actually see that there's a Xamarin.Android tab down here. So let's click on that. We'll see a bunch of calls to what it's actually doing behind the scenes. So again, as I mentioned in my talk, what actually happens here with the Android platform is the code gets compiled down into IL and then gets deployed along with the Mono VM and sits side by side with the Dalvac VM and the Java framework. So that's good. That's all loaded. Everything says that it's ready. We've got Tasky Pro with push. This is loading, so we're now logged in as Larry, which is great. So we should eventually see a notification appear, and we have. So if we pull this down, so you'll see it says Tasky Pro registered, ready for notifications. So this means that it's now hooked up to Azure Mobile Services. So if we go and have a look back in our console and we look at our data tab, we should see after a few seconds that it has a second device registered. So you see that updated. If we click here, we should see Larry. So Larry is a GCM user, as we would expect, and Larry's service key is somewhat longer and different format to the service key that APNS provides us back with, but that's fine. They're just, at the end of the day, text string, so they're just of a different length, which is fine for our use. So we can dismiss that. We're not that worried about it. So let's go ahead and add a task. So in this case, we'll get a soft keyboard. So let's go and send a message. Let's assign that to Tim. Okay, we'll close this. We'll click Save. Alright, so you probably won't have seen that because it's happened quietly in the background, but if we look here, there was actually a notification came up on the iPhone. So let's go and open Tasky on the iPhone. We should see after a few seconds that Tasky Pro crashes on me. Thank you very much, Tasky Pro. Let's try again. Hopefully at some point it'll decide that it wants to get some tasks. Let's just see if we can wake him up. No. Alright, well, let's exit out of there. We'll close him. And what we'll do is let's just send Tim another reminder. So let's pull up Tasky on our Android handset. So Larry is logged in. Okay, so it's going to tell me it's registered for notifications. That's great. That's good. Let's add a task. Let's get these so we can see both screens at the same time. Yep. So let's click in here. We'll assign this again to Tim. And let's close this. We'll save this. So if you watch the iPhone on the left side, so there's our new task. So we can click on that and it will behave. So you'll see there we've got a notification inside the application as well, which says new task, a new tablet. So that's a difference between a notification when the application's actually tombstone versus when the application's actually open. And then if the list loading logic was correct, we'd see that task show up on the list here. So I might come back and have a look and see how we can fix that later. So we should also be able to get the reverse happening now. So I should be able to create a task down on the iPhone. Let's pull up the iPhone task. Well, that's some good typing right there. Okay, so we'll leave Larry as the signee, and then we'll save it. Let's see what we get over on the... Oh, that was quick. There we are. So we've seen the iPhone create a task and assign it to Larry, and he's almost immediately gotten a push notification to that effect. So that's probably a bit quicker than you'd usually see, but these are running on my cable connection here in Sydney, so they're not open to the vagaries of 3G data comms. Alright, so let's go ahead and dismiss that. Let's just go home. We'll have to come back and have a look and see why those guys aren't actually displaying their list of tasks, because they should be. Let's just open him up, see if we can convince him to show that task. No. Okay, I might have to have a look at that logic and come back to it. So that's 2 out of the 3 platforms that we've got there, which is great. So so here we are with our Windows Phone 7 code project open inside Visual Studio. Changes we've made to this application to get it to work with Azure Mobile Services and push notifications in particular. On application launching, we call a new custom method called register for notifications, and what this method does is it uses standard way to register for notification notifications that come down from MPNS, and then to once it receives the information, to actually register it up into our user device registration table for the user Steve, and to denote that he's an MPNS user. It's important to note that the channel URI can change, and this may be through an installation of a new version of the application, or because of some other back-end service change that requires that the channel URI be updated. So we need to cater for that. So what we do is, in the event that that does get raised, we simply insert that item again, which is a fairly simple way to handle it. If you remember earlier, we saw that we have an insert Node.js script sitting in front of the mobile services database table, which will essentially delete any matching items for the user Steve, and that's what we're looking for to handle this particular scenario. Most of the other handset platforms don't work this way, but this is a fairly flexible way, and one that you would need to cater for in any design that you come up with that has to deal with the three mobile platforms. So if we just quickly look at the Azure management console, we'll see in here in our user device registration table we have our two users from before, Tim and Larry, and what we're now expecting is that when we run the application that we've got open here in Visual Studio, that we will actually register this device as well. The other item of note is the task details page, is that we can either load the task by ID by calling Azure Mobile Services, and again we're using the async await keyword, so that we can actually allow proper threading to occur, and our caller here will wait for that item to complete. On save, we'll actually push the task down out to mobile services and save it in the task table, and then we've got some marshalling of values out of the assignee picker that's actually being rendered on the screen using the coding for fun controls. Registering our Windows Phone 7 app so that it receives notifications is pretty straightforward, or how we get Azure Mobile Service to actually do that. So what we need to do for this is we actually need to use the Live Connect Developer Center and then sign in. So I'm already logged into Azure Mobile Services using the account that I want to use. So I click on the My Apps tab here at the top. Okay, so they just want to confirm that I am who I say I am. So I'm just going to log in again. Alright, so I'm going to create a new application, so I'm going to call this one Tasky Pro 3. It's going to be English US. I'm going to accept it. Okay, so we're going to say this is a mobile client. So what we need to do is we need to take the client ID from here into our mobile services push tab, and that becomes our package SID. So I have one here already from an app I've previously used in this space. And then the client secret. So we're going to copy that and paste that into our space here, and then we're going to save that. Yes. So what we've now done is we're now allowing Azure Mobile Services to impersonate our application when they send our messages via MPNS. So if we save this, so that's all we need to do for this particular setup. Right, so let's go ahead and run our Windows Phone 8 application. I'm just going to fire him up. So our emulator loads. Okay, cool. So in our register for notifications method, we'll see we've just got a breakpoint here. So we're going to send a registration out to Windows Azure Mobile Services. So we've got a valid channel URI key. So you'll see here it's actually is in the format of a URI, which is different to the other two service providers, but that's fine again. Still a string, so we can store it in the same table. So let's just go ahead and F5 that. Steve's task list loads, and then we should hopefully find there's his one and only task as assigned. And if we flip back to Azure Mobile Services and we refresh this table, we see now Steve's got a registration in here and holding his MPNS key, which is good. And we should find that if we send a task into the task table for Steve, that he will actually get a push notification. So let's leave the Tasky Pro app open here, and what we'll do is let's use the Android emulator, and we'll actually add a task, and what we'll say is we'll sign this out to Steve, close our keyboard, we'll save this. So we should hopefully see, okay, good, we've just broken inside of our push notification channel shell push channel shell toast notification received method. So we'll just F5 on that. So there's our notification. So we can also tombstone the app so it's closed. We should get a native notification on this one. So we'll click in here. And we'll assign this one to Steve as well. We'll close the keyboard and we'll save it. Okay, so there we actually got a native push notification versus the notification inside of the application itself. And then what we should actually be able to do, if we come into the Windows Phone and we scroll down to Tasky Pro with push and open him up. So again, we're going to re-register our device on startup. So there's our tasks loaded. Let's click on plus. Excuse me, we'll leave that assigned to Larry. We'll save that, and then we should be able to see over here, if we haven't already missed it. Not yet. So let's just go and check in mobile services, see what we got in here. So that was sent to Larry. For whatever reason it set the notes to null, but that's fine. So Larry should still get the notification at some point, I hope. Let's create a new one for Steve, see if we can get the iPhone doing something for us. We'll assign this one to Tim. Save that. Okay, so there's a in-app notification, which is cool. So we can dismiss that. We would theoretically see that appear in the task list inside the iPhone app as well. Let's just see if we've had one over here on Android. I have found that sometimes the GCM service takes a while to forward messages through, but that's fine. They may well show up in due course. So let's just go have a look in the Google API console and see if we had anything show up at all. Okay, so it's not showing any updated stats as yet. That's fine. So that's really the end of this demo. I hope you found it very useful and informative, and show you that you can build essentially the same application across 3 of the leading mobile platforms that are in the market today. That being obviously Windows Phone 8, iOS. So at the moment this is showing a demo using iOS 6, but it will in future also support iOS 7, and Android, whatever flavor it is that you may be looking to target. So thanks a lot for your time today. I hope you found this useful, and it's filled the gaps for you as far as the work that was supposed to be shown at TechEd, and I hope to see you in 2014. If you have any questions, please feel free to go over to my blog at blog.siliconvalve.com and leave me a message there. You can follow me on Twitter at Simon Waite, and that's SIMONWAIGHT, or alternatively you can email me at simon.waite@cloud.com.au. Thanks a lot for your time, and I'll speak to you later.